Today we'll talk about a fun topic, interactions. And so we'll start by introducing an example here and then see how interactions help in this example. Miles per gallon is a measure of fuel efficiency. And in this auto data set, we model miles per gallon as a function of weight and whether or not the car is foreign. This auto data set stems from, I think, the 80s or 90s. And when we say foreign, we are referring to a foreign car from the US perspective. The data come from consumer reports in the US. The other thing is that the cars in 80s and 90s in the US were typically heavier in America than they were in other countries. So much for the data. Now we run a regression, MPG on foreign and weight, and la-ti-da, weight is significant. Ooh-ha, which way? As we increase weight, the average MPG decreases. That makes a lot of sense. Do whether or not the car is foreign matter? No. Okay, so now we know. This gives rise to two different models, depending on whether the indicator variable is turned on or off. And for foreign cars, we have beta 2 times 1 the indicator, which we can add to the intercept. And so really what we have is the same model as for domestic cars, meaning US domestic cars. And for foreign cars, except for foreign, we have a different slope, right? Beta 0 versus beta 0 plus beta 2. So here we have a fit of that model visualized. The blue squares are domestic cars, and the red triangles are the foreign cars. We know the lines must be parallel because they have the same slope. That's by design in the model. And I think for the blue squares, that looks pretty reasonable, right? When I look at the shape of the data. Now, if I look at the red ones, you see me circling. That maybe doesn't look reasonable, right? So maybe there should be a different slope, at least a different slope, maybe even curvature. But at a minimum, I'm wondering whether we need a different slope. So something like here, right? Because then we have some points over there, over here. There's one unusual observation. There's always one, even in statistics. Well, so how can we come up with a model that accommodates this funny yellow line? Different slope. All right. We create a new variable called f_weight. Well, the name doesn't matter, of course. This new weight is a new variable is 0 if foreign equals 0 and takes the value of weight if foreign equals to 1. This is the exact same thing as multiplying foreign times weight, the indicator of foreign times weight. Because if the indicator is 0, then the whole thing is 0. If the indicator is 1, then we get weight. So this is equivalent. We call this a two-way interaction because it's the product of two variables. So we get a new model, and the new model is the same as the old one with an additional variable. So when we add a two-way interaction, we still include the original variables, right? That's actually important for interpretation. So we include the original variables and then just add the interaction variable. The computer cannot actually tell that this is an interaction. It just thinks there's another variable. Okay, now we can do this model game again, depending on whether the foreign indicator is turned on or off. We get now two different models. Before, without the interaction, we got a different intercept, beta 0 versus beta 0 plus beta 2. Now, because of the interaction, we also get a different slope, beta 1 versus beta 1 plus beta 3. Now, where does this come from? Because if the car is foreign, then the interaction is turned on, and the interaction, when it's foreign, equals to weight. So I get my beta 3 plus weight here at the end. and then I factor out weight, and then I have beta 1 plus beta 3, which is basically saying I have a different slope and I have a different intercept. Both models are, of course, still linear. Then I can interpret these coefficients in sort of in a straightforward way. Yes, I'm going to leave you to read that and move on. Look, here I'm generating a new variable and creating a new variable, and it's really just the multiplication of these two variables, right? And then I'm regressing, having added the third variable, and I get a different result. Now, by the way, our R squared, 69%. Not bad for 3 variables, not bad at all. So here I have weight is significant, direction is the same as before. The interaction is significant at 5%, is significant. And which effect does it have? Well, if it's turned on, the slope decreases even further, right? The slope decreases, this is a negative slope, and if it's turned on, it's even more negative. Well, it's larger in absolute value, but still negative, but more negative sounds good. So what happens is the decrease is even stronger for foreign cars as a function of weight. Okay, that's interesting. By the way, foreign, the indicator is now marginally significant. I'm saying marginally because it's close to 5%. Of course, if I chose 5%, then I would just have to say it's significant. But we know it's sort of marginally there. And foreign cars have a positive coefficient, which means if you are foreign, then you have more fuel efficiency and quite a bit more. Well, I don't know what the measurement of weight is right now. But so, yeah, foreign cars are more fuel efficient. All right, here is the model fitted. We have 2 intercepts as before, and now 2 different slopes. And if we look at the red ones here, this line does seem to fit better. Of course, we have one unusual observation there, an outlier maybe. But here we also have an unusual observation, and there's always one, right? Even in statistics. All right. So this seems to have done the trick. We're happy. I'm happy. And so let's go on. This is the code from the previous plot, just for completeness. So it sometimes takes a little bit to wrap one's mind around this idea of an interaction, because it's not something that people who first hear about it expect. It's sort of a little unusual. The other thing that's unusual about interactions is that when scientists, like psychologists or social scientists, ask about this, they don't ask a data scientist, well, can you fit an interaction in that model? They may ask you that, then you get lucky, but they may not know what they're looking for as an interaction. So part of the skill is to understand that what they're asking for really is an interaction. And so here are 2 equivalent statements that somebody who doesn't know about interactions might ask, and you then have to realize, I understand what you want. It's an interaction. You don't know that, but that's exactly what you want. So here is one question. Does the weight of foreign cars affect MPG differently than that of domestic cars? So the weight of foreign cars affects MPG. So we're talking about the slope of weight here, right? And it affects it differently, meaning the slope is differently than that for domestic cars. So are the 2 slopes different? Second question, same thing. Is there a differential effect of weight? The effect of weight is beta on MPG. Well, effect of weight on MPG. By whether or not the car is foreign. Asks the same question. Do the slopes differ? Good. A two-way interaction is the product of two variables. When one of the two variables is binary and the other continuous, the interaction allows for differential slope. Next, we will look at an interaction between two binary variables. But this is the end of this segment.